Welcome back. Today we're going to look at solving systems of linear equations using algebra. Last time we looked at looking at the graphs and finding the intersection if there was one. This time we're going to use some algebra to solve systems of linear equations. And the first method is called substitution. The idea of substitution is we solve one equation for a variable and we substitute it into the other equation. Here's an example. Suppose we have this system, x minus 2y equals 4, and I'm calling that equation 1, and 2x plus y equals 13, and we'll call that equation 2. So I want to solve this system algebraically using this method substitution. The first thing is we look at our equations and we figure out if we can solve one of them for one of the variables. The easiest one I see right now is I could solve this top one for x. So I could solve equation 1 for x. So if I do that, what we end up with is x equals 4 plus 2y. We move the 2y over, we add 2y. Now I can substitute this back into equation 2. So if I rewrite equation 2, let's say I rewrite equation 2. I'm going to rewrite equation 2. We get 2 times x plus y equals 13. But x is this here. So rather than writing x again, I'll write 4 plus 2y. So 2 times 4 plus 2y plus y equals 13. So now we have an equation that has y's only in it. And we can solve this for y. So if we continue on solving this equation, we get 8 plus 4y plus y equals 13, using the distributive property, multiply through by 2. And then we add the y's together and move the 8 over, so we're going to do this all in one go. If we add the y's, we get 4y plus y is 5y equals, and we move the 8 over, subtract 8 from both sides, 13 minus 8 is 5. And finally, if we divide both sides by 1, we see y is equal to 1. That's one of our solutions. So y is equal to 1. So we know y is equal to 1. We can now substitute this back into here to solve for x. So if we do that, we get x equals 4 plus 2 times 1, because y is 1. And 2 times 1 is 2, 2 plus 4 is 6. So x equals 6. So that's the other part to our solution. So if x equals 6, y equals 1. So our solution is 6, 1. That's the intersection of those two lines. That's the point that there's a solution to both of these equations. Now, really, once we find this answer, 6, 1, we should test it in both equations just to check. So let's do that. Let's check our solution. So we're going to check this solution 6, 1 in both of these equations. In equation 1, we have x minus 2y equals 4. So plugging in 6 for x and 1 for y, and we get 6 minus 2 times 1. Is that equal to 4? We see 6 minus 2, well, that's 4, and 4 is equal to 4. So that's fine. That's equation 1. That's checking in equation 1. And we do the same thing in equation 2. 2 times x plus y equals 13. So 2 times 6 plus 1 equals 13. Is that true? Well, 2 times 6 is 12 plus 1 is 13. Yes, that's true. So equation 2, it also checks out. So this indeed is our solution to point 6, 1. And you can also verify this by graphing these. In order to graph these two equations, you would have to solve each one of these for y and then put them into your graphing calculator. So let's just look at that. Suppose you want to solve the system of equations x minus 2y equals 4 and 2x plus y equals 13 using the graphing calculator. The first thing is to solve each one of those equations for y. So x minus 2y equals 4. If you solve that for y, and I'm going to skip some steps there, but you might want to verify this, y equals x minus 4 divided by 2. So we put that in our graphing calculator, turn it on here, and we go into the y equals editor, and we're going to put in parentheses x up here where the variable is, x minus 4, close parentheses, all divided by 2. So that's our first equation. The second equation, 2x plus y equals 13, if you solve that for y, you simply move the 2x over, we get y equals 13 minus 2x. So under y2, we're going to put y2 equals 13 minus 2x. So there are our two equations. Now we want to graph these two equations and we want to find where they intersect. Generally, if I hit graph, all kinds of windows can come up. So to get a standard window, we normally go zoom right here, and then number 6, which is the standard window. You could also scroll down to the standard window and hit enter. That gives you a window from negative 10 to 10 on each axis. If we look at our two lines, here's one line, here's the other line, and I'll leave it to you to guess which one is which. This is a positive slope, negative slope, so you can think about that. But we want that point of intersection here. In order to find an intersection, if the graphs intersect, using the graphing calculator, we have to click second and then trace. And we scroll down to the function number 5, which is called intersect. Then we hit enter, and you want to scroll close to that intersection where you see those two lines are hitting each other. Scroll close to it, not right at it, but close to it. Once you're there, hit enter again. The second curve is the other line. Hit enter again. It says guess. It's not really guessing, it's doing an algorithm to calculate it. And then enter, and you'll find here's the solution. At x equals 6, y equals 1, that's our point of intersection. In other words, this point 6, 1, which is right here, is the solution to this system of equations.